In this video, we're going to continue with the theme of structured exception handling and talk about coding exception handling into our apps. Specifically, we're going to talk about how to find those exception objects that are specific and pertinent to our situation. So in the previous video, we talked about the what and the why in regards to structured exception handling. What is exception handling? Why do you need structured exception handling? What are the benefits and things of that nature? We also then demonstrated the use of the try-catch and finally and talked about how to use specific exception objects within your application. But then I'm sure in your minds the question came up, well, if it's true that there are dozens or even hundreds of exception objects, how do you find the exception objects that you need to use within your application? And so I guess there's a couple of ways you could go about this. You could, first of all, just go through the documentation and study and memorize all the exceptions that are even possible. And that's not really realistic. If there are dozens or hundreds, you're not going to be able to do this. However, there are probably a handful that you're going to need to remember, like the argument null exception or maybe the null reference exception. I mean, you're going to get those on a daily basis as you develop your applications, and maybe you forget to do this or that as you develop. But for the most part, you're not going to know all the obscure exceptions that are possible within the .NET framework. The other way is that, and probably the most prominent way, is that you're going to use help for the methods that you create, or rather for the methods that you use in the .NET framework. So now I'll demonstrate the technique I use to find all the exception objects that I'll need to watch out for in my application as I develop it. You might recognize this example. It's from the previous video. And what I'm trying to do is create a new file stream object, passing in the name of the file and telling it that I want to just simply open the file. And I'm going to set it to an instance called FS. Now, as I look at this line of code, I notice that I'm passing in parameters and that there's a lot that could potentially go wrong here. So I want to look at all of the exception objects for the file stream object. So I'm going to select it by double-clicking the name and then hit F1 on my keyboard. And when I do, it'll bring up a list of all the file stream members, the properties, and the methods. Specifically, what I want to look for are the constructors, because I am using the new statement to create a new instance of the file stream. So I'm going to select this. And in this case, it's going to ask me to select the specific method signature for the overloaded list of methods for the file stream constructor. I happen to know that I'm using the string file mode version of the new constructor, so I'm going to go ahead and select it. And here is the documentation for the method. First of all, you'll notice that we have the method signature itself, and then the parameters that we would pass in, a longer description of each of the parameters. And then we come to the exceptions, and this is where we're really interested for the purposes of this video. Now, you're going to have some exceptions that are common to virtually every method that you look at. In this case, argument exception, the path is an empty string. Argument null exception, path is a null reference. These kinds of things you're going to see in just about every single method. It might be named a little bit different, but essentially it's the same thing. But here are the ones that are specific to opening up a file. File not found exception, IO exception, directory not found exception, path too long. So all these are types of things that we know could happen when dealing with the file system. Perhaps the file is not found, as we found in the previous video, or the directory is not even found, or maybe the path name exceeds 256 characters. These are the types of things that if we allow users to enter this information in, we'll want to check before actually trying to perform this operation. And I'd probably want to make a specific error message for each one, or at least handle it in a different way, give the user some specific options, an option different for the file not found versus perhaps the IO exception. Want to give them a different message, different options that they can choose from in order to make better decisions about how to proceed from this point. So I would want to go back then to my code and add catch statements for each one of those. Now, there's another way to find out what the exceptions are that you would be interested in, and that would be to simply create a breakpoint at the exception line. Go ahead and run the application, and after it begins running, Let me pull my watch window down a little bit here. What I'll want to do is highlight my E object, which has been set to an instance of the exception object that's been returned. I'm going to drag and drop it down in my watch window, and notice that I can now expand the E object and look at all of its properties. And in this case, I can see the message, could not find the file CLVS text. I can take a look at the stack trace and go into the details of that if I wish, and take a look at the actual message of the stack trace here. And by looking at these things, I can deduce where the actual problem is at. And most importantly, I would take a look at the system.io.filenotfound exception. This tells me the specific exception that E was cast to. And now I probably want to check for that as I create my application. Now there's one other way to do this. I can make it a little bit easier on myself rather than doing that method, and that's simply to create a new string and then set s equal to e dot message or source or whatever I prefer, in which case then I can add s to the watch window. Let's do that really quick. Change our. And sometimes this is a good method if you want just a simple explanation. You can leave this down here, and in this case I guess I didn't execute that line of code just yet. So here I can see the exact error message without having to drill in and search for the actual message. So it's just another way of doing it. I actually prefer to do the first method because this is it gives me the ability to drill in and look at all the information about this particular exception. But these are the ways that I would go about finding any exception objects that I'll need to work with in my application. So I hope this was beneficial.